Hey, it's Mr. K doing a video for AP Physics 1. We're looking at vector addition. This is going to help you out with anything that has vectors that are applied to things. So pretty much every single topic that we do. A vector is just something that has an amount and a certain direction to it. And so here we have vector A and vector B. It could be two vectors of force, could be two vectors of displacement. You got to make sure they're the same thing if you want to add them together. And so we're going to talk a little bit about graphical and algebraic vector addition. A plus B, if we were to do that, vector A is going to go straight up. Vector B is going to go up and to the right. Here's A and here's B. B would go something like this, and we're going to use what's called the tail to tip method, or the tip to tail method, where we use the tip of one and we attach the tail of the other, and we draw one kind of stacked going from one to the other. So here's vector A, here's vector B, and when we add these together, we connect them from tip to tail, and the resultant, the total that we get, would be from very beginning to the very end. It would be this red arrow there that would point up and to the right. And if we were to just look at that red arrow, that red vector, it would have a piece in the horizontal and it would have a piece in the vertical. Okay, and so for the red vector, we call that the resultant. Once again, the resultant would have a base of, let's say, 1, 2 to the right, and it would have a height of 1, 2, 3, 4 up. Okay, and if you look at the properties of the vectors that we added together, vector A here has a 2 up value, and B has components of 2 to the right and 2 up, because really B, if we want to work this in one dimension at a time, has a horizontal component and it has a vertical component. And so whenever we do math, we always do one dimension at a time. So this is the graphical addition of vectors, where you do the stacking tip to tail. We can also do the algebraic addition of vectors. And in order to do that, we need to say, hey, if we're going to add A to B, what we're actually going to do is we're going to add AX plus BX, and we're going to add AY plus BY. And so AX is nothing, but BX is actually 2, whereas AY is 2, positive, and BY is also 2, and that's going to give us 4. And so here we can see that our values added together algebraically, only the horizontal added to the horizontal, gives us a total horizontal of 2, which is right there. Then if we look at only the verticals, that gives us a total value of 4, which is over here. And so our resultant will have a 2 in the x component and the 4 in the y component, and the resultant value itself would be the hypotenuse to this triangle. And so back from math, probably your favorite equation ever, a squared plus b squared equals c squared, Pythagorean theorem, except now we're not talking about just a and b in total. We're talking about the horizontal side 2 squared and the vertical side 4 squared, and that's going to equal c, or in other words the hypotenuse. We're going to square root that. So 2 squared is going to be 4, plus 4 squared is going to be 16, that's going to be 20, square root of 20 gives me a value of 4.47. So 4.47 would be the value for the resultant. That would be the length of it. And to be a little bit more appropriate here, we would have to find an angle. And I know all three sides now. I'm going to go ahead and use the sides that I know directly, not the calculated side here. And so that's the opposite side and the adjacent side. Well, if I remember my trigonometry, or if I don't, here's my little helper, SOHCAHTOA, to help me out. I've got opposite, I've got adjacent. I'm going to use tangent. We know tangent of an angle is equal to the side opposite divided by the side adjacent to that angle. And in this case, we have the opposite, we have the adjacent. We really need the angle, and that's where you go and hit second tangent to get the arctan or the inverse tangents. And all you do for these is you just plug in that ratio to it to get the angle. So I want to plug in the ratio of opposite 4 divided by adjacent 2. Okay, and that's just going to be 2. And so the tangent inverse in second tangent of 4 over 2 is going to be equal to about 63.43 degrees. So 63.43 degrees will be the angle here, and that will be almost good enough. We have 4.47 at 63.43 degrees, but we need to be a little bit more specific, so we could say above the horizontal. But that might not be specific enough, because above the horizontal could be 63.4 degrees the other side of the horizontal. So let's do even better. Let's say this is 63.43 degrees, and we're going to say north of east. And so you would imagine that we have a compass, and we know that north is up here, south is down here. And if that's the case, then you've got east to the right and west to the left. And so this angle, if you look at it, it is measured 63.43 degrees north of east, and so we know exactly where it is. If it was 63.43 degrees north of west, it would actually be over in this side of our quadrants. If it was 63.43 degrees east of south, it would be more down here. And so because if I just say 63.43 degrees, it could be up here, down here, over here. There's like 8 different varieties of choices. North of east gives us exactly the one that we're talking about. All right. So vector addition, vector subtraction would work in the same way. If we said vector A minus vector B, all subtraction is, and I'll use these little vector notation, little arrows on top here, all subtraction is adding the negative. And so we would say, oh, well, here's AX, and we would say plus the opposite of BX, and AY plus the opposite of BY. And all that really says is, instead of going to the right and up, B would instead be flipped the other way, and it would go to the left and down. And so here AX is going to be nothing. But BX is going to be negative 2. AY is going to be 2. But BY is going to be negative 2. And when you added, or actually when you subtracted vector A, or vector B from vector A, then what you get is going to be this negative 2 in the x direction, and you're going to have a 0 in the y direction. So all you're going to have is this. Okay? And that's the visual representation of it. Because vector A went up. Let's draw it over here. That would be vector A. And the opposite of B would be not up and to the right, but it would be down to the left. And I would end up right there. And so visually speaking, you should be able to see that our resultant vector is going to be this one, which we got algebraically first in this case, and then we showed it graphically or visually. All right, so you might be thinking, why would this even matter? And so if you had a problem, there's a problem on your homework, or you should be on your homework, where you've got a plane, and this plane is flying south. So let's say we have a vertical view of a plane, something like this. Draw some tail things on it. There's this. So there we go. We got some kind of plane. It's flying south, and there's some wind. And so this plane would have a velocity vector that points in the southerly direction. And let's just make up a number. Let's say that it's like 300 kilometers per hour. So rather quick. Maybe not too quick for a plane. But then it says, hey, maybe there's some wind. And this wind comes from the southwest. So if we look at our compass, the wind is coming from the southwest. So it's coming from over here, and it just says southwest, so it's going up to the northeast. So really this wind is trying to push this plane, and it's a velocity vector that goes 45 degrees in this direction. And let's say this wind is like 100 kilometer an hour wind. Okay? And so the question is if, well, first of all, this isn't scaled right. This would be a lot bigger if this was 300 and that was 100. So forget about that. But if we have a plane that's just trying to fly due south, 300 kilometers an hour, if there's some wind that's pointing up northeast, coming from the southwest, pointing up northeast, then this plane, you can kind of tell, it's going to start to drift over to the east. But also it's going to be slowed down a little bit. This 300 is not going to be 300 anymore. And so all you do is you combine vectors to find out what the actual velocity of the plane is. And so to do that, you just say, all right, well, it's 2 dimensions, right? So if it's 2 dimensions, then we probably need to do 1 dimension at a time. And so I'm going to look at this wind vector here, this velocity vector for the wind, and I'm going to take that apart. And I'm going to say, all right, this is 45 degrees because, you know, this is 90 degrees, so we're like halfway. Northeast is halfway. And if that's 45 degrees, I can just take 100 times the sine or cosine of 45 degrees. It's good enough. And I get 70.7. 70.71. And so this is 70.71 kilometers an hour. This is 70.71 kilometers an hour. And so if we're flying into the wind, then this 300 is fighting 70.71 kilometers an hour. So I'm just going to say 300 minus my answer that I just got, and that's going to give me 229.28, 229.29. So overall, this plane has a vertical or a southerly velocity vector that's shorter than what it was before of 229.29 kilometers an hour. Okay? And I got to add in this part to it too. So now it also has a velocity vector that's to the right or to the east of 70.71 kilometers per hour. And so overall, which way would this plane go? And you got to be careful here because some people would want to connect the tip of this arrow to the tip of this arrow, which would make it go in this direction, but that's incorrect. Remember that these 2 components are part of a whole that should go down and to the right, so really it should point this way. Okay, and to find the value of it, we need to take 229.29 and we need to square it. And we need to add that to 70.71 and we need to square that. And then we need to square root it because this is Pythagorean theorem. We need to find that last side of the triangle. It's 239, let's call it 240. This is 240 kilometers per hour. Okay, and then we got to be a little bit better than that. We got to give a little bit of a direction here. And so let me give this angle here. And so do I know the sides to this triangle that I'm talking about? And I should, because this side is 70.71, the horizontal side. The vertical side is 229.29. And so I need opposite over adjacent, and that again is going to be tangent inverse. Opposite is going to be 229.29. The adjacent is going to be 70.71, and if I do this, it's going to give us an angle. So inverse tangent 229.29 over 70.71 gives me a value of 72.86 degrees. So this altogether, this plane would be going 240 kilometers per hour, 72.86 degrees. But we need to be very specific. We're measuring south of east. Okay, and that's going to tell me exactly where we are. So anytime you have a problem with multiple vectors, you need to work this in 1 dimension at a time, because that's how math works for us humans. Alright, so we look at only the x's and only the y's, and if you need to, split it up. Break it up into pieces. Okay, and this is going to help you on every single problem. If you're stuck on the trigonometry, take 10 minutes. Figure out what trigonometry for sine, cosine, and tangent is. Sine. This is the last little bit for this video lecture. Sine of the angle is going to be the ratio of the side that is opposite to that angle divided by the hypotenuse, that longest side. Cosine is going to be the ratio of the side adjacent to that angle divided by the hypotenuse. CAH. Tangent is going to be, again, tangent of the angle is going to be the ratio of the side opposite to the angle divided by the adjacent side. And so that's what the SOHCAHTOA will help you with if you forget. But as you use it more and more and more, it should be a lot more clear to you what's going on. So this is a simple application of it. In the future, you might have a bunch of vectors that you would have to add together. But the secret to adding a bunch of vectors together, let's say we have all these vectors like so, the secret is to add only the x's and only the y's. And so if we had these 4 vectors, you would first try to find the pieces that make them up and simply add the pieces together in only the x or only the y. And that would make your life a lot easier. Alright, we'll end the video here.